occurs at the middle of a transmission line as shown in figure. Find the fault current. Now what is the fault current for LG type of fault? IF is equal to 3 times of ER by x1 plus x2 plus x0. Okay, now let us take ER as 1 per unit, so this will be x1 plus 3 by x1 plus x2 plus x0. So what is this x1, x2, x0? x1 is positive sequence fault equivalent, and x2 is negative sequence fault equivalent, x0 is zero sequence fault equivalent. Now what is positive sequence fault equivalent? We have to find that one. Okay, positive sequence fault equivalent is drawn between phase and neutral. Okay, now when you draw this one, phase and neutral, we will have reactance values like this. This is for generator, transformer. Since it occurred at middle of the transmission, positive sequence value given as 0.4 per unit, so this should be equal to 0.2 per unit. Fault occurred, let us take at this point. This is generator positive sequence reactance, which is 0.3 per unit. Transformer he has given as x1 is equal to x0 is equal to 0.1 per unit. Okay, since it occurred middle of the transmission line, this is another part of the transmission line, that is 0.2 per unit. After that we have one more transformer, this one is 0.1 per unit. After that we have generator, which is equal to 0.3 per unit. Okay, now this is the positive sequence equivalent circuit for the network shown in figure. Now what is xt1? xt1 is found between this fault point, so xt1 is equal to 0.3 plus 0.2 plus 0.1 is in parallel with what is one more 0.2 plus 0.1 plus 0.3. So what is xt1 value? xt1 is equal to 0.6 by 2, which is equal to 0.3 per unit. Similarly, negative sequence fault equivalent. Okay, the same diagram we will have because it is also drawn between phase and neutral. So xt2 is equal to, okay, now if you see here the values are different. Okay, so we have to find again equivalent circuit. This is 0.25 he has given. After that, transformer same as earlier, positive sequence reactance, middle of the transmission line. Okay, so this is the fault point. Transmission line negative sequence is given as 0.4 per unit, so this is 0.2 and this is also 0.2 per unit. Okay, after that we have one more transformer, this is 0.1 per unit. After that we have a generator, negative sequence reactance is 0.2 per unit. So this is the equivalent circuit for negative sequence reactance. So xt2 is equal to 0.1 plus 0.2 plus 0.25. So this is 0.55 parallel with 0.55. So what is the answer? 0.275. Okay, per unit. Now the important one is zero sequence fault equivalent circuit. Now what is zero sequence fault equivalent circuit? It is drawn between phase to ground. Okay, so type of connections in transformer is and generators are very important here while you are drawing zero sequence fault reactance. Now since we have star grounded, so star grounded, this is the, let us take as ground equivalent, ground point, whereas these two are neutral and neutral. Okay, now we have to draw, since it's star grounded, we can grounded this one. And what about the zero sequence reactance for the generator, which is equivalent to 0.2. Okay, after that we have delta. Delta means shunt connection, so primary is delta circuit, primary is delta, so we have to operate shunt switches. Okay, transformer reactance is 0.1 per unit. Okay, after that secondary is star grounded, so we can operate the series switch here since it is grounded. Okay, and Since fault occurs at the middle of this transmission line, what is a half of that zero sequence reactance? Since it is given as 0.5, half of that 0.5 will be 0.25 per unit for this transmission line. Okay, now fault occurred at this point. This is 0.25 since it is divided into two parts. After that we have a connection of star by delta. Okay, since it is star winding is not grounded here. Okay, in the figure he has given this one as star by delta. Since this transformer is not grounded, we should not operate the series switches. Okay, so this is open circuited. After that we have delta connection, so this is grounded. After that we have star connection. Okay, this is isolated one which is having a reactance of 0.2 per unit. Okay, now this one is 0.1 per unit. Now what is the fault equivalent? We have to calculate between these 2 points. If you calculate this between these 2 points, xt naught is equal to, okay, xt naught or x naught is equal to 0.35. Okay, only these two will come into picture if you see from this side. This is what xt naught. Okay, now what is fault current here? We have already seen this. Fault current IF is equal to 3 times of 3 by x1, that is xt1, which is equal to 0.3 plus x2, which is equal to xt2, 0.275 plus x0, that is xt0, zero sequence fault reactance, so which is equal to 0.35. Okay, we will get it as 3.24 per unit. That is option B is the correct answer. 2 kilovolts transmission line having critical disruptive voltage VD is equal to 80 kilovolts per phase. Okay, V phase is equal to, he has given 132 kilovolts as line, so 132 kilovolts by root 3, this is 76.21 kilovolts. Okay, now VD is greater than V phase. We know that corona loss PC is directly proportional to V phase minus VD whole square. Okay, if you see here the relation between VD and V phase, critical disruptive voltage VD is 80 kilovolts, okay, which is greater than that of phase voltage of 76.21 kilovolts. Okay, what does it mean? That phase voltage is far less than that of critical disruptive voltage. At this point of time, critical disruptive voltage only corona loss starts. Okay, since there is no chance of operating voltage which can be greater than that of 80 kilovolts per phase, that means there is no corona loss. PC is equal to 0 watts. Option A is correct.
Find the root locus for an open loop transfer function g of s and h of s equals to 1 by s power 4 minus 4. That is g of s, h of s, we can write s square minus 2, s square plus 2. So the pole locations are plus or minus 2 plus or minus j root. There are 4 poles. Okay. Here, see, there are 4 asymptotic angles. Those are, if we calculate the asymptotic angles, q2 cube plus 1 into pi, number of poles minus number of zeros equals to, these are the asymptotic angles. I am indicating with pi. We will get as a 45, 135, 225 and 315 degrees. So asymptotic follows the poles are going to move from here k equals to 0 to k equals to infinite, means the poles are going to follow the asymptotic path in this way. Hence option B is correct.